Rightio, question 3. Water is leaking from the hole at the bottom of a large tank. The volume of the water in the tank at time t hours is V cubic meters. The rate of decrease of V is directly proportional to V cube. So the rate of decrease is going to be negative. So dV dt proportionality is directly proportional to the cube of the volume. So we've got that. Remember, it's negative because this is a decrease. Don't like the alpha. We replace that with constant times. That's my differential equation. B. Given that V is 60 when t is 0, show that V squared gives me that where A is constant. So this is very similar to question 1, I think. Separate the variables. Pop it into index form. It's not ln. Integrate, add 1, I get minus 2. So I get V to the minus 2 over minus 2 equals minus KT plus C. Okay, so I can write that as minus 1 over 2V squared equals minus KT plus C. And I've got my initial conditions. When t equals 0, V equals 60. So minus 1 over 2 times 60 squared equals 0 plus C. So that means C is equal to minus 1 over 60 squared times 2, 7,200. Now, I'm quite happy with that because that's double 3,600. So I think I'm on the right track. Go back to the hideous fractiony bit. Do the same as we did last time. Combine that fraction. So it's going to be all over 7,200. That's over 1. 1 goes into 7,200 times, so you have to multiply the top by that. So I get minus 7200 KT minus 7,000 goes into that once. 7,200 goes into that once. 1 times 1 is 1. Multiply throughout by minus 1, and I get 1 over 2V squared equals 7200 KT plus 1 over 7200. Now that they're all complete fractions, I can just invert the 2 or cross multiply, whatever you're happier doing. So I get 2V squared is 7,200 over 7,200 KT plus 1. Take the 2 over and it'll divide. So I get V squared is basically halving that and halving that. Gives me the 3,600 over 7,200 KT plus 1. Look at what we're trying to get. And I'm nearly there, apart from I got an A. So if I let A equal to 7,200 K, so I'm letting 7,200 K equal A, then v squared equals 3600 over AT plus 1 as required. That's what we wanted. Pleased with that. So I've done part B, 4 marks. Part C, when T equals 2, the volume of the water in the tank is 50 cubic meters. Find the value of T when the volume of water in the tank is 27. Give your answer to 1 decimal place. Okay, so I'm going to rewrite my expression. So I'm going to have to go back to the previous page. When T equals 2, V equals 50. So 50 squared equals 3600 over 2a plus 1. 50 squared, 2a plus 1 equals 3600. 2a plus 1 equals 3600 over 50 squared. .44. So 2a will equal 0.44. Take the 1 over. A will be 0.22. Give your answer to 1 decimal place. Oh, sorry, no. Find the value of T when the volume, I haven't finished. So A is 0.22. Thought that was strange, making me run that. So my expression, my equation, is going to be 3600, excuse me. Oh, sorry. 0.22T plus 1. And the question wants me to find the value of T when the volume is 27. So when V equals 27, 27 squared is 3600 over 0.22T plus 1. 27 squared bracket so I get that. So 3600 divided by 27 squared is that. So T is going to be that minus 1 divided by 0.22, which is 17.9 to 1 decimal place. And the units are in hours. So it's 17.9 hours to 1 decimal place. So that's question 3. Let's be brave and keep going. What could possibly go wrong? Question 4. I could possibly go wrong. Part of the surface of a small lake is covered by green algae. The area of the lake covered by the algae at times T is A meters squared. The rate of increase of A is directly proportional to the square root of A. So it's an increase. So it's a rate, so it's dA dt is directly proportional, so it's not negative, to the square root of A. Don't like the alpha, So I'm going to write that as dA dt equals k, and I know I'm going to have to integrate, so let's get that in index form, but if you left your answer as k root a, that would be fine. Part B. The area of the lake is, when t equals 3, is 64, and covered at 5.5 is 196. Find an expression for a in terms of t. Okay, so first of all I need to get in the form a equals, so I have to solve. I'm going to have 1 over a to the half dA equals k dt. Write that in index form. So it's the minus a half. I add 1 to be plus a half, and I divide by that. So I get a to the half over a half equals kt plus c. That's going to be 2a to the half equals kt plus c. Right, let's have some initial conditions. When t equals 3, a is 64. So 2 square root of 64 equals 3k plus c. So that's going to be 816 equals 3k plus c. I got two unknowns, so I can't do anything more with that yet. I need to go back to my question, and I know that when t is 5.5, a is 196. So this time I've got 2 root 196 equals 5.5k plus c. Square root of 196 is 13, I think. 14. So I've got 28 equals 5.5k plus c. So now I'm cooking. So if I do equation 2 take away equation 1, I get 28 take away 16, which is 12, equals 5.5k take away 3k, which is 2.5k, and c take away c, gone. So k is 12 over 2.5, which is 4.8. I need now to work out what c is. So if I put that now in 1, I get 16 equals 3 times 4.8 plus c. 16 equals times 3, 14.4 plus c. So c would be 16 minus 14.4, which is 1.6. So I now know what my k value is and what my c value is. Find an expression for a in terms of t. So that's what I'm trying to do. So for a in terms of t, so now I have 2a to the half equals, so what I'm doing here is going back to the solution, the general solution to my differential equation, and replacing the k and the c that I worked out. So k is 4.8 t plus 1.6. can divide throughout by 2, and I get A equals 2.4t plus 0.8. Sorry, that's to the half, and then I can square, and I get A equals 2.4t plus 0.8 squared. You could take out a common factor there, but there's no need to. It's not a show that, it's perfectly correct, and you can stop there. So those are the pure maths questions on differential equations. In the next video now we'll take a look at the mechanics ones.